Hello again. This is lesson 5 over sinusoidal functions unit. This is investigating models of sine functions. Now that we know how to graph a sine function from an equation, we need to look at creating equations from graphs or word problems. So first one, a nail located on the circumference of a water wheel is moving as the current pushes the wheel. The height of the nail in terms of time can be modeled by the graph below. So writing equations from graphs, what we need is we have to know our k value, our a value, our c value, and we will worry about the d value afterwards. And we also have to choose a parent function. Okay, you don't have to write this every time. You'll get used to it. But we need to know if we're using sine or cos. Okay, so there's 4 different options. We have y equals sine x, which looks like this. We have y equals negative sine x, which looks like this. Y equals cos x, starts at the maximum, and y equals negative cos, which starts at the minimum. Okay, and right away we can see with this function that we're looking at on the graph, it starts at the maximum, so we're going to be using a cos function. It's not always going to start at one of these spots, but you can look, is the maximum or the EOA or the minimum closest to 0? That's the function that you want to use. Okay, the k value. So in order to get the k value, we need the period. So let's go just take a look at maximum and maximum. The period is when it goes from one part all the way through the cycle back to that starting point. So I'm using the maximums here, and the period is 10 seconds. So in order to do the k is 360 divided by the period, which is 10. So the k value here will be 36. Okay, the a value, or amplitude, we know is the maximum. So the maximum is at 3, the minimum's at -1. So it's the maximum minus the minimum divided by 2. 3 minus -1 is 4. 4 divided by 2 is 2. And then we have the c value, which is the maximum plus the minimum divided by 2, which is 1. Okay, so our EOA is at 1. Okay, good. So we can put some of this together into an equation. So we have fx equals, we know our a value is 2. We chose a parent function of cos. Okay, our k value is 36. There is no phase shift because when the time is at 0, we're starting at our maximum. So we'll just leave it as x, and the EOA is 1. So there is an equation for this graph. Determine the equation of given graph. Okay, we just did that. There are actually an infinite number of possible equations. We could choose a negative cos and use the phase shift here. We could choose a positive sine and use the phase shift here, or a negative sine and use the phase shift here. So there are multiple different ways to write this equation. We're looking, the most correct one, or the most proper one, is closest to the y-axis. Okay, a sinusoidal function has a maximum at 6 and a minimum at 3, -3. The period is 10 and it goes through the point 0, 6. Okay. Because the maximum is 6 and it starts at 6, so it's telling us that it starts at the maximum. So the parent function we would choose is cos x, because cos x starts at the maximum. Okay, our a value. So we find the a value, the amplitude, by our maximum minus our minimum divided by 2, and 9 divided by 2 is 4.5. Okay, we get the c value, the equation of axis, by adding our maximum and our minimum and dividing by 2, which is 1.5. The k value is 360 degrees divided by our period, which is 10, 36. And there isn't a phase shift. So we can write this equation as it's positive 4.5 because it's starting at the max. Cos, no phase shift, so 36x plus 1.5. Okay, if you're given this information, you don't quite understand where phase shift would be if you wanted to do sine. So just show you that quickly. If you choose y equals sine x, okay, so it's most proper to choose cos because it starts at the maximum, but what if you don't want to? We're going to use our equation that we just created. We're going to change cos to sine, and we're going to add a phase shift that we don't know. Okay, but we do know that it goes through the point 0, 6, which is an x and y. So we can replace the y with 6 and the x with 0. Okay, so the first thing we'll do is get rid of the 1.5. So we get 4.5 equals 4.5 sine 36. 0 minus d is just negative d. Okay, we're going to divide by 4.5 to get rid of that. So we get 1 equals sine of negative 36d plus 1 point. Oh, sorry, we already got rid of the 1.5. My mistake. Okay, to get rid of the sine, we will sine inverse the 1. So we get 90 equals negative 36d, and then we'll divide by negative 36 to isolate the d. So d is negative 25. Okay, so if you wanted to do sine x, you do all this work to find your phase shift and then write the new equation. So gx equals 4.5 sine k value of 36. We have x plus should be 2.5 plus 1.5. Okay, a lot of work. So it's much easier just to choose the cosine in this situation. Okay, one more. Sinusoidal function has a maximum at 6, again a minimum at -3, again a period with 10, but this time it goes through to 1. So now we're doing what we just did, but keeping it cos. Okay, everything, so nothing is changing except for the starting point, the phase shift. It's no longer at the maximum at our y-axis, but we're still going to figure it all out. So A, it's the same as above, but we're still going to show you 1.5. K is still 360 divided by 10, which is 36. Okay. So this time there is a phase shift, so we're going to, it's going to be cos, but we're going to have an x minus d. And we're going to plug in 2, -1. So y is -1. And x is 2. Okay, we get rid of 1.5. We divide by 4.5. Oops. We cos inverse. We don't need the brackets there. So 36, 2 minus d. Okay, and then we'll divide by 36 to get rid of this. So 3.437 equals 2 minus d. Subtract 2. 1.437 equals -d. So -1.437 equals positive d. So our equation that we're left with is 4.5 cos, k value of 36, x plus 1.437 plus 1.5. Okay, finding equations.